Welcome back to the second part of this chapter on MRP and ERP. We're going to finish the chapter, talk about some of the outputs of the MRP processing, and then go on to talk about the other evolutionary parts of MRP and what enterprise resource planning is and kind of where we are today with this particular technology. Now, one of the things that MRP software will do just as part of its natural programming is a process that we refer to as pegging. Pegging. So the definition of pegging is this. Pegging is the process of determining the source of a requirement, the source of a requirement, or to say it another way, what was the parent part that generated that material requirement. So let's take a look at the slide, the two bill of materials shown in this slide. So we see that we have a finished product A, which consists of requiring one B and one D. And we have also finished product C, which requires two D's and one F. So D is needed on both parents. It's needed on parent A and also needed on parent C. Now, let's take an example. Let's say that we need to deliver 100 of the A part and 100 of the B part. And at this point, we're going to ignore the timing dimension of when we need them. Let's just say we need 100 of each. So in order to produce 100 A's, I'm going to need 100 D's. That's assuming I have no inventory of D's. And in order to produce 100 C's, I'm going to need 200 D's, since it takes 2 D's to make 1 C. So if I need 200 D's and to make the 100 C's and 100 D's to make the 100 A's, I need a total of 300 D's, a total of 300 D's. So let's say that we have someone that we buy this part D from, and so we give them an order, and we say we need 300 D's, and we need them on a certain date. And this particular company comes back to us and says, well, you know, I've got a little bit of a problem. I can't give you the 300 D's. I just don't have them on the date that you're wanting them. But what I could do is I could give you 100. Will that help you if I give you 100? Well, if you were the material planner, what you would need to know is, in order to answer the question, could I use the 100? I would need to do pegging. I would need to take a look and say, well, I need 100 D's. Okay, will that do me any good? And the answer is yes. If I could get 100 D's, that means that I could finish that order for 100 A's. I couldn't get the C's, but I could at least get the A's. So pegging is a very important piece of information whenever we're doing material planning, especially when we run into the situation which I've just described. So when MRP processes and runs, it would be nice if things didn't change. But the fact of the matter is that we live in a very dynamic world, especially the world of manufacturing. Things change every day. Things change almost to the minute. So what types of things can change us? Well, we could have new orders come in. We could have customers call us and say, you know, that I wanted to have this particular quantity. I've changed my mind. I want more. I want less. Or they could say, I've changed my mind. I want them earlier. I want them sooner. We could discover that certain inventories that we had, we really didn't have as many as we thought we did. So the inventory balance can change. We could have suppliers who missed deliveries. There's just all kinds of things that could change by minute. So what we'd like to do is to try to have our MRP plans, our time phase requirements, as accurate as possible. So for that reason, we're going to have to run our MRP program, fairly often. In some cases, we may need to run it more than once a week. When I worked at Texas Instruments, we ran MRP twice a week. So it kind of depends upon how dynamic your situation is. And each time we run it, we want MRP to take into consideration all the changes that have taken place and to readjust the time phase requirements to the more accurate dates. So from an output perspective, what are the outputs that come out of MRP? Well, it's going to create planned orders. So when it sees that your projected on-hand inventory becomes negative, it's going to try to fix that, and it's going to create an order and says, here's when you need to have it. And it's going to tell you that this is when you need to start executing a particular planned order so that it's going to be finished whenever it needs to be finished. And it's going to come out, tell you what all the different changes were from one MRP run to another MRP run. Now, in your textbook, it refers to some secondary outputs, but I can tell you from personal experience that the third bullet point on this particular slide is the most important output that comes out of an MRP run, and that is the exception reports. So in a typical manufacturing environment, you're dealing with hundreds of thousands of different parts. And there are just not enough hours in the day, and there's just not enough employees to try to manage all these hundreds of thousands of parts. So what you need is help, and you need a computer system such as MRP to tell you that out of these hundreds of thousands of parts, there's a certain percentage, usually a fairly high percentage, where everything is okay. You're in good shape. You don't need to do anything. But then there is another subset that's in trouble. And these are things that require your professional attention on and require you to figure out how you're going to work with these problems. So the exception reports are intended to help a planner focus. There's only so many hours in the day. I want to try to focus my time on the most important things. And the exception reports are going to show what are the things that are late, that are overdue, and that's where I need to spend my time as a material planner. It's going to also show some planning reports and some other things, but the big one, of course, here are the exception report. Now, when MRP runs, it's going to use as part of its inventory information a certain lot size policy. So the definition of lot size or lot sizing is these are our inventory management rules that we define for each part. So if we need to make more and buy more, how many, what is going to be the quantity or the order size of that particular run? And there are any number of different lot size policies or rules that we could have. And they all have their good points and they all have their bad points. And there's no one optimum lot size policy that is the absolute best. They all have their good points. They all have their bad points. We'll talk about a few of them in this slide right here. So the first one is called lot for lot. And the definition is shown here, but let me give you what I think may be a little more simpler definition of lot for lot. Lot for lot means what you need is what you get. What you need is what you get. So in our MRP processing, if it determines that our net required is 10, then the order size will be 10. What you need is what you get. On a different part or a different time period, if the net required is 50, the lot for lot is 50. On another part, another time period, if the net required is 1, the lot size is 1. So the good thing about lot for lot is it is guaranteed to minimize your inventory. You will never, ever make or buy any more than you absolutely need. That's a good thing. The bad thing is that sometimes you're not achieving the best efficiency. To make one part is not very efficient. It's usually more economical if I make more than one. So lot for lot is not interested in efficiency. It's interested in minimizing your inventory. So it has its good points and its bad points. Economic order quantity. Now, we've already studied the economic order quantity, so that's a lot size policy. We know that it is that quantity that is going to minimize our total cost. Another lot size policy shown on this slide is fixed period ordering. So in fixed period ordering, what I'm going to be doing is I'm going to aggregating the demand over some predetermined number of time periods and creating an order that is equal to that aggregated or some demand. So let's take, for example, let's say that over the next, you have a fixed period ordering policy of three periods of demand. So what that says is whenever I have a net demand, a net requirement, I'm going to take whatever that quantity is in that time period. I'm going to look at the 2 next consecutive time periods and look what the net required would be for those. And then I'm going to aggregate the sum of those 3 net requirements, and that will be the order in which that I place. Now, safety stock can be planned for in MRP. We've covered safety stock before, but again, as a reminder, safety stock is an additional amount of inventory that I wish to carry over and above the actual amount that I actually have to that is required. So the purpose of safety stock is to give me a certain amount of protection against the uncertainties of demand and also the uncertainties of supply. So if I choose to use safety stock in my planning, MRP is going to include that in its calculation. Now, there's another way in which I can plan for these uncertainties and these variabilities, as the slide refers to, certain uncertainties, and that's referred to as safety time. Safety time. So the difference between safety time and safety stock is that safety time will schedule things to arrive earlier than when they are actually needed, but I'm not ordering any more additional quantity. I'm just asking for it to come in earlier than when it is actually needing. So I'm protecting myself with time, where safety stock is trying to protect yourself with more inventory. Now, from a practical point of view, you would never, ever, ever want to use both of these techniques together, safety stock and also safety time. All that does is exacerbate your inventory levels. So not only would you order more than what you were needed, but you would be bringing it in even earlier than when you needed, and that even increases even more your inventory carrying cost. MRP can be used in the service industry as well. So the next time that you go to your favorite fast food restaurant, McDonald's, for example, okay, they have end items. They have the sandwich items, the burgers, and so forth, and that would represent independent demand. And in order to make those burgers, they require dependent demands. They require the bun, and they require the hamburger patty, and the lettuce and tomatoes and any of the other ingredients that go into that sandwich item. So essentially, that's MRP. So they need to use MRP just like anybody else. Hotel renovation, yeah. I can remember working in my career with an electric utility company. Electric utility companies, one of the things that they're responsible for doing is in order to meet the electrical demands of the citizens in that particular area, they have to constantly to construct different electric utility substations. So the electric utility substation could be viewed as an end item or independent demand, and all of the transformers and all of the other components that are required for that electric utility substation would be the dependent demand. So just another example of how MRP is also used in the service industry. So what are the benefits of MRP? Well, there's a number of benefits. First of all, MRP is used by literally many, many people within the business. Not only the operations folks are going to be using the MRP outputs, but the accounting and the finance people are going to be able to use MRP for cash flow purposes. They'll be able to look at the MRP results and to calculate what the cash flow will be for the business to make sure that we have a positive cash flow. So many people will be using it. Some of the biggest benefits for the companies that have really done MRP correctly is it reduces their inventories. And if we can reduce inventories, it's going to save the company a tremendous amount of money. It also gives us the ability of keeping track of literally these hundreds of thousands of different materials. If we didn't have MRP, it will be very, very difficult to try to keep track of all the materials. It also helps us to evaluate our capacity needs as well. So what does it take to implement an MRP system? I can tell you from personal experience that it takes a great deal of work. It takes a great deal of planning to do it. But the things that are also shown here are also very important. So the three inputs into MRP, the master schedule, the bill of materials, and the inventory records, we had said that we're assuming that all these are computerized records. They need to be accurate. They need to be accurate. The bill of material needs to be accurate. The inventory information needs to be accurate. And one thing that you should know is that the MRP program has no magic within it. If there are any inaccuracies in any of these computerized databases, the inventory information, MRP has no way of knowing that that information is incorrect. It's going to process it with the full faith assumption that it's correct. And the result will be that the MRP time-phased requirements are wrong. And people are working to the wrong schedules, and they're working to the wrong dates. So we have to make sure that this information that we're feeding to MRP is correct. So the old expression, garbage in, garbage out, is true here. If we send in garbage information, as inputs, then the output, unfortunately, is going to be garbage as well. Now, going back to a historical point of view, the decade of the 1970s was considered the Great MRP Crusade. After a number of years, the companies that had successfully implemented MRP started to get together, and they started to say, you know what, this MRP thing is pretty good, but you know what, we can make it better. Let's make it better. So there was kind of an evolutionary stage that took place next. And the next evolution of MRP was referred to as MRP Roman numeral 2, or in this case, MRP actually stood for something a little bit different, Manufacturing Resource Planning, MRP2, where the original MRP stood for Material Requirements Planning. So MRP2 was an expanded approach to the original MRP, which brought a lot of additional capabilities that was not included in the original Orlicki work on MRP. So here's a look at MRP2. So if you take a look at the very center of this diagram, you'll see a box that says MRP. That's the original MRP. And so with MRP2, what we did is we hooked together the areas shown in green in this diagram. So we said, let's hook the overall production plan, or the aggregate plan, which we've talked about in a previous schedule. And the aggregate plan is built on top of the business plan. So let's link up the business plan and the aggregate plan to MRP. So that was one of the big enhancements. The other thing was, let's put in some capacity checking. So after we run the production plan, we can do a capacity check. And then if you'll notice in the orange box just below the MRP, we see another capacity check take place there too. So not only do we want to be able to have a MRP plan that's linked to the business plan, but we want to make sure that it is capacity feasible. Capacity feasible. That is that we have enough material, we have enough employees, enough machine capacity to be able to do the plan. So MRP2 is also referred to by the term closed loop MRP. Okay, so we're linking the capacity plan. If it's not correct, that means we need to go back. We need to maybe make some changes in the master schedule so that we come up with a plan that is capacity feasible. So capacity requirements planning. By definition, capacity requirements planning is the process of determining our short-term capacity requirements. In other words, in order to produce a certain quantity of this particular item, how many hours of a certain machine are going to be required, and on what date are those hours required. So once I know what the capacity requirements are, I can then compare that to what the available capacity is. And if the capacity required exceeds what the available capacity is, then I've got a problem. I don't have enough capacity, and I need to look for a way of resolving that. Now, in planning, I'm going to be planning for some time in the future. We had referred to the master schedule earlier as needing to at least be equal to the cumulative product lead time. So in planning, the things that need to be done in the short term. The short term could be defined as things that need to be done this week, maybe next week, maybe up until the next month. it is important that those plans not have a lot of change associated with them. You know, we like to be responsive to change, but if we are trying to be too responsive to change, and if there's too much change, we can't get anything done. Nothing can get done. You're just constantly going around in circles trying to adapt to change. So it's important that in our planning that we have a certain period of time that we refer to as stable. We're not going to change the plan in this short term. We don't want the system, the MRP system, to be nervous, to be making a lot of changes in this time, because we want to be focused and we want to at least get that done. Now, further out in the future, when things are not quite so dynamic, any changes that need to be done in that, yes, let's go ahead and make those changes to that. So in the near term, we want to have a time fence. Time fences are essentially rules, rules to say that anything that's going to be done in the next month is frozen. We're not going to make any changes. Okay, so the nearest time fence is the most restrictive. We don't want to make any changes in the next month. Anything that needs to be done beyond the next month, yeah, we'll think about making changes that need to be done in that, because we have some time in which we can adapt to those changes. So, capacity requirements planning in MRP. So this slide kind of shows how we might go about that. So we need to take the MRP plan, and the third green box shows convert that material requirements to the resource requirements. So we need to take, if we need, for example, to produce a certain quantity of a particular material on a certain date, we need to know what machine it is required to produce that quantity. And we need to know how many machine hours are required to produce one of them. So let's say it takes 1 hour to produce one unit, and we need to produce 100 units on a given date, then we need 100 machine hours, 100 times 1. So that's the capacity required, 100 machine hours. And we know the date that we need it. So we can compare that to what is the available capacity on that particular date on that machine. Do we have 100 machine hours? If the answer is no, then we need to go through a process of evaluating, well, is there any way in which we can increase the capacity on that particular date in order to meet the required capacity? If the answer to that is no, then we need to go back and we need to change the master schedule and either reduce the quantity or change the date to get that down. If the answer is yes, we can change the capacity, we can increase it to meet what the required quantity is, then that means there's no need to change the master schedule. We might need to work some overtime. We might need to bring in some more employees to work on that particular machine to help out. So in our capacity requirements report, one of the things that will come out of the output is called the CRP report. So if we take a look at the graph here, you'll see a dotted horizontal line that goes across the graph. So that dotted horizontal line represents what our available capacity is for this particular work center or machine. And see, we see different time buckets. So we see that the height of each of the bars, the vertical bars, represent the capacity that is required. So we have right now, we have some work that is sitting right in front of the machine right now. That's stuff that is waiting to be worked on at the machine. So we see that over a period of time that kind of decays off. We work that off. And then we have in the yellow part or the gold part some work that has not yet come to the machine. So it's not expected to come to that machine for maybe another several time periods. So the time periods in which you see the vertical bar is higher than the horizontal dotted line. That means that we have a more capacity that is required than we have capacity available, or we have a capacity overload situation. And then we have to look to see how we could resolve those capacity overload situations. Now we'll come to the final evolution in this story, and that is after our closed loop or MRP systems were implemented for a number of years. Again, the companies got together and they said, you know what, we can make this even better. And so we had the next evolutionary step. And this one is referred to as Enterprise Resource Planning, or ERP. And ERP takes us to our current day. So today, this is the state of this particular capability. ERP systems are still available today. And we'll see that even in the ERP systems, at the core of the ERP is the original MRP that was created by Joseph Orlicki. So Enterprise Resource Planning Systems essentially is one very, very large information system that supports the needs of the entire enterprise or the entire corporation. So not only does it do all the other things that we've talked about in this chapter, but it also is going to do all your accounting and all your marketing and all your human resources and literally everything that needs to be done within the company is contained within one extremely large, extremely complex information system. So ERP systems are a very, very strategic part of an operation strategy. They have an extremely high initial cost. Enterprise resource planning systems cost in the millions of dollars, extremely expensive, but they have the potential for saving millions of dollars. That's why corporations are willing to make the investment. They have a great deal of training required in order to use them, and they affect essentially everybody within the company. So almost all employees are going to need to be trained, and they're going to need to be able to use the ERP system. And they're going to make everything work better. The supply chain processes, all the procurement processes, all the inventory management processes are also going to be improved with an ERP system. So this concludes part B of this lecture. Also be sure to take a look at the other parts that are also used as a supplement to these lecture slides.